Welcome to Concepts in Chemistry. In this talk, we will discuss the three levels of representation in chemistry. So what are these levels? The first level is called microscopic, the second level is called particulate, and the third level is called symbolic. So what is the microscopic level? The microscopic level describes the properties of things we can perceive with our senses. So what are our senses? Our senses include sight, smell, taste, touch, and hear. And what are examples of things we can perceive with our senses? Examples include color, texture, taste, smell, hot, cold, heavy, light, pressure, mass, and so on. Next, what is the particulate level? The particulate level describes things we really can see with our eyes, but they are there. So what are examples of things we can't see with our eyes, but they are there? Examples include atoms, electrons, protons, neutrons, ions, and molecules. Next, what is the symbolic level? The symbolic level uses symbols to describe the particles that exist at the particulate level and the relationships between them. So what are examples of symbols used under the symbolic level? Examples include chemical symbols, chemical formulas, chemical equations, mathematical formulas, molecular models, charts, and so on. Which is why when you go into a chemistry classroom or a chemistry laboratory, you always see a periodic table. And the periodic table lists all the elements that we currently know. So among these three levels, which level does the chemist value the most? The most important level to a chemist is the particulate level. Why is the particulate level important? The particulate level is important because once a chemist understands the behavior of atoms and molecules, they can apply this understanding to synthesize new molecules with unique properties, which of course will help in curing diseases and solving other problems. Now, if we can't perceive the particulate level with our senses, then what then does a chemist use to explore the particulate level? The chemist uses technology. So as you can see, science depends on technology to advance, and technology also depends on science to advance. So they are interdependent. Which is why when you go into a chemistry lab, you always see different instruments. Examples include gas chromatography, liquid chromatography, NMR, and so on. All these instruments really help the chemist explore the particulate level. Now, at the microscopic level, what determines the properties we observe at the microscopic level? What determines the properties we observe at the microscopic level is usually due to how the atoms or molecules arrange at the particulate level. So that means that the properties we observe at the microscopic level is always as a result of the interaction of molecules or atoms at the molecular level. So the properties at the microscopic level is always a collective effort, okay? These properties always occur based on how these atoms or molecules interact with each other or arrange at the particulate level. So as a result, the properties at the microscopic level are usually called bulk properties. Bulk in the sense that it is a collective effort involving these atoms or molecules. So the next thing is, why is it that chemistry is always difficult to understand? Now, chemistry is always difficult to understand because it's abstract. Why is it abstract? It's abstract because of the particulate level. Because the particulate level involves particles that are invisible to us. And because they're invisible to us, it's difficult for us to understand. Because we human beings always want to touch and feel things. So if we can't touch and feel things, it's always very difficult to understand. Which is why you need to spend a lot of time when studying chemistry. So you have to spend time studying it, reflecting on it, building models to help you understand what really goes on at the particulate level. Now, let's see how water can be represented using these three levels. Okay. Now, so we all know that based on our daily experience, we all know water can exist in three states. Okay, so the states are gas, liquid, and solid. So when water exists as gas, we normally see it as steam. When it exists as liquid, we see it as water. And when it exists as solid, we see it as what? Ice or snow. Now, when water exists as pure water we see it as colorless. When it exists as ice or snow, we see it as white. Okay. Now, at a particular level, how do we represent water? Usually, water consists of what? Water molecules. So at a particular level, we always try to use models to represent water molecules. So an example of using models is the model right here to represent water. So as you can see, at a particular level, because water consists of hydrogen and oxygen, we normally use a red circle to depict oxygen as I've done here. And also these two dark circles here depicts hydrogen. Okay, so it's just a way of saying that water consists of what? One atom of oxygen and then two hydrogen atoms. So hydrogen and oxygen molecules react to make water. And once they make water, water exists as what? H2O. So a whole unit consisting of two atoms of hydrogen to one atom of oxygen. So this is a particle model of water molecule. So a collection of water molecules, and depending on energy, temperature, and the intermolecular forces, the interaction between these water molecules, the way these interactions play out determines whether we'll have a gas, we'll have a liquid, or we'll have a solid. Okay, so again, as I pointed out, energy, the interplay between energy, intermolecular forces, and then temperature. Okay, so depending on these conditions, depending on temperature, energy, and the intermolecular forces, the water molecules can arrange at a particular level to either form a solid, liquid, or a gas. Now, at a symbolic level, how do we represent water? At a symbolic level, we normally use the chemical symbols of the atoms that really reacted to form water. So in this case, hydrogen and oxygen react to form water. So as a result, we normally use it to form water. Here, you don't see a number by oxygen, but one is implied. Okay, this means that it's just one atom, which is why you don't see a subscript attached to it. So anytime you have a chemical formula with no number attached to the chemical symbol, it usually means that one is implied. Okay. So H2O. Okay. So again, water can exist in the three states depending on the interaction of what? Energy, intermolecular forces, and then temperature. Okay. So depending on these conditions, water molecules can arrange to form liquid, gas, or solid. So sometimes you hear about conceptual understanding. What does that mean? Now, it just means that you understand whatever you are studying in chemistry at all the levels. Okay, so in this case, we've talked about water. So if you understand the behavior of water, then you should know that water at a microscopic level can exist as a gas, as a liquid, and a solid. And it can exist in all these three states depending on energy, temperature, and the intermolecular forces. Okay. You also know that at a particle level, we normally draw particle models to represent water. So again, you should be able to draw a particle model of water molecule, which is right here. Okay. And also, you should know the chemical symbol of water, which of course is H2O. Okay. So once you understand water, the behavior of water and its properties at a microscopic, particulate, and symbolic level, we normally say you have conceptual understanding. So where students always strive to be in this particular triangle is to always strive to be in the center of the triangle. So once you're in the center of this triangle, then that means that you understand what is being discussed at the microscopic level, the particle level, and the symbolic.